So the problem is a object with a weight of 23 newtons on an inclined plane of 17 degrees with the coefficient of friction of 0.22. So step one is to draw the free body diagram. So first off, you draw an arrow straight down, which is the weight, and next is a perpendicular weight. And then after that, you draw the parallel weight, which starts from the head of the perpendicular weight arrow and all the way to the head of the normal weight arrow. And next is the normal force arrow, which is always parallel to the perpendicular weight. And next is the frictional force, which is always, again, is opposite of motion. And in this case, the object is going downwards, so the frictional force will be going against it, which is in this direction. Next step is to find the mass. So the equation to find the mass is weight divided by gravity, and weight is negative 23 newtons, and gravity will always be negative 9.8 meters per second squared, and that will give you a mass of 2.3 kilograms. Step 3 is to extract the triangle from the free body diagram. So a triangle will have an angle of 17 degrees, which is from the inclined plane, and this is the weight arrow, which we already know, and it's 23 newtons. So you use sine and cosine to help you find the values of weight perpendicular and weight parallel. So to find weight perpendicular, it'll be 23 times cosine 17 because it is adjacent over hypotenuse, and that'll give you negative 22 newtons. And make sure to include the negative sign in your answer because the weight perpendicular line is going downwards, so therefore you'll need a negative sign in your answer. And for weight parallel, it'll be 23 times sine of 17 degrees, which will give you 6.7 newtons. But again, you have to put the negative sign because the arrow is going towards the left, and you need a negative sign to indicate that. Step 4 is to find the normal force. So you use the equation weight perpendicular plus the normal force, which equals 0. So weight perpendicular is negative 22 newtons, and after you solve, you'll get 22 newtons as a normal force. Step 5 is to find the frictional force. So first you use the Fun equation, and the coefficient of friction is 0.22. Multiply that to the normal force, which is 22 newtons, and you'll get a frictional force of 4.84 newtons. Next, you use the weight parallel plus the frictional force equation. So weight parallel is negative 6.7 newtons, and once you solve, you'll get a frictional force of 6.7 newtons. However, you use the frictional force, which is less, because an object will not exert an excessive amount of energy. It'll only exert what it needs to. So therefore, you use the value that is less. In this case, it's 4.84 newtons. Step 6 is to find the sum of the horizontal forces. So use the equation sigma f of x equals weight parallel plus frictional force. So weight parallel is negative 6.7 newtons. You add the frictional force, which is 4.84 newtons, and you'll get negative 1.86 newtons. Step 7 is to find the acceleration in the horizontal direction. So you use the equation sigma f of x equals mass times acceleration in the x direction. So you solve for the acceleration in the x direction, which will give you sigma f of x divided by mass. Sigma f of x is negative 1.86 newtons. You divide it by the mass, which is 2.3 kilograms, and you'll get an acceleration of negative 0.81 meters per second squared. And once again, make sure you remember to keep your negative sign in your answer. And finally, the final step is to state all the forces. So when you state all the forces, make sure you state all the ones in the y direction in the same group, and you also list all the forces in the x direction in the same group.